Hi, this is a video to explain lesson 9.10, problem number 43. The directions say to find the Maclaurin series for this given function f of x. I know the Maclaurin series for sine, and so I'm going to just write out the first few terms of that. I'm going to remember that sine at 0 is 0, so this one has no constant term, just a 0. And then the next term is x to the first over 1 factorial. And then my next term after that is going to be negative, because I remember that sine and cosine both alternate. This is x to the third over 3 factorial plus x to the fifth over 5 factorial, and so on with the odds. So if I wanted to write this in sigma notation, I certainly could do so. I know I need a -1 to some power because I have alternating signs. I know that I have factorials in the bottom, and those are all odds. So a way to get even expressions is to say 2 times n. So a way to get odds would be to either add 1 or subtract 1 from that. I'll go with adding 1. And then that is going to determine what my index starts at. So I want my first term to have a 1 factorial in the bottom, so I need my n to start at 0. And so if my n is starting at 0, if I make this n, then plugging in 0 is going to give me -1 to the 0, which is 1, and I do want this to turn out positive. So that seems like it will work well. And then I have x up on the top, 2 powers that match the factorial in the bottom. So I have 2n plus 1 factorial down here, so my exponent is 2n plus 1, and this is a series, meaning that it is exactly equal to the function because it has an infinite number of terms. So that's what I'm looking at for sine. So the particular question that we had was to look at x times sine of x. So what I want to do is just multiply through by x. So I just need x times this. So I'm going to take this whole expression and multiply it by x. So each term, term by term, gets multiplied by another x. So now the exponents and the factorials no longer match because I'm gaining an additional factor of x in each term. And this would go on forever. And if I wanted to express this in sigma notation, I could just take this previous sigma notation. And what I'm imagining in my mind right now is multiplying by another x there. And if I'm multiplying things with the same base, I know that I add the exponents, and so that's what I'm going to show. I'm going to show everything is the same, except that I have an additional x. And down here, this stayed the same. Nothing changed about the factorials. And that is my solution.